Good day, my name is Yovendiran Nagasvaran from 4BEEE Section 1 Group 2. Today I will be presenting about my system, which is development of Ingenious eyeball motion detector system. Now, for my project description, the globalization in terms of innovation and technology has grown and reached the peak of its value, where ordinary people who are physically challenged face difficulties to own futuristic aid to help them performing their daily tasks. This specific project is invented to reduce their burden to the least of 70% in terms of costing, where everyone will be able to use this sensor to interface with any device to perform any specific task just by using their eyeball motion with a very low and affordable price. Introduction. Physically challenged pupil is basically challenged with their disabilities. Globalization brings needs for more human effort based innovation and technologies, but is still deniable for physically challenged pupil, as it is being a barrier for them to perform any task anywhere, anytime. Problem statement for my project is sensor-based applications dominates the real world for multitasking. Autonomous industry makes sense of increasing efficiency and time limiting factors. Less innovation in terms of serving physically challenged individual, and these innovations for disabled are not in terms of autonomous and still requires the effort of triggering in input in order to perform specific tasks. Therefore, my objective focuses on three main things, which is number one, to develop sensor for detecting an individual's eyeball movement. Number two, to analyze data of the sensor for device used according to an eyeball movement. And number three is to study the best way of sensor integration that can fit any form of system or device. Now, let's move on to methodology. In my project, I used QTR1A infrared reflectance sensor as an input, Arduino Nano development board with Atmega 328 microcontroller as the controller of the project, and RGB LED as the output. QTR1A infrared reflectance sensor working principle is the same with the infrared sensor. 2 units of QTR1A infrared reflectance sensor used for each eyeball. Detection range of the QTR1A infrared reflectance sensor varies between 0V DC to 0.98V DC. 0.985 indicates object detected, while 0V indicates no object being detected. When the left sensor and right sensor is both in the optimum level, which is the 0.985, then the LED blinks indicates that the user is blinking their eyes. When the left sensor is more than and equivalent to 0.985, while the right sensor is less than and equivalent to 0.985, the eyeball on the RGB LED moved to the left indicates that the user is moving their eyes to the left, while the left sensor is less than equivalent to 0.985 and the right sensor is more than and equivalent to 0.985, the eyeball on the RGB LED moved to the right indicates that the user is moving their eyes to the right direction. Now, let's discuss about the result and analysis. According to my project, this is a very straightforward analysis whereby infrared sensor works in a principle with 0 and 1 condition. 0 is when no object is detected, 1 is an object is detected. Otherwise, In part of creativity in this project can be explained in terms of project demonstration made up using NeoPixel RGB LED, which indicates the movement of an eyeball of a user. Besides, inventiveness of this product can be explained in terms of innovation, where this system can detect an eyeball motion just by using a QTR1A infrared reflectance sensor, which in return proved to be effective and user friendly besides being cost efficient. Now, let's move on to the most interesting part, which is the project potential of commercialization. The project potential of commercialization in Malaysia is very much possible, as according to a survey conducted, a product which is user friendly and cost efficient will be the most potential for the commercialization purpose in Malaysia. According to a survey as far as 2020, Malaysia possesses minimum of 30% of physically challenged poor individual, whereby they are challenged by their physical disabilities and also by their financial crisis or financial freedom. This financial status in Malaysia can help in the project potential commercialization, as my project is user friendly and cost efficient. While many are using advanced system to develop an eyeball motion detection system, we just managed to come out with the development of an ingenious eyeball motion detector system just by using QTR1A infrared reflectance sensor and an Arduino Nano. Now, let's have a quick review of my schematic diagram. This schematic diagram shows that Arduino Nano interface with two units of QTR1A infrared reflectance sensor and RGB LED. This schematic is drawn using a Proteus software. Now, let's take a look on the developed product. A figure here shows that the QTR1A infrared reflectance sensor is mounted together with the spectacles, and the eyeball here is for a demonstration purpose made up of RGB LED. Now let's look what happens when the eyeball is in a ready state. This is a condition when the eyeball is in a ready state. This is a condition where the eyeball moves to left. This is when the eyeball moves to the right. And this condition here when the eyeball is in a blinking state. Now let's take a tour to observe the developed product and how it is used. Okay, as we are looking over here right now, this is the Arduino Nano development board with the Atmega 328 microcontroller. And this is the QTR1A infrared reflectance sensor. And finally, this is the eyeball made up of RGB LED. For more information, this QTR1A infrared reflectance sensor is mounted with a spectacles.